So in this video I'm going to prove to you that the Pythagorean theorem is true. I start off by drawing two squares of identical area. So both these squares on the left and on the right have the same area, and that's why I'm putting an equal sign in between them, because I'm comparing the area of both squares and they're the same. On the left side I'm going to draw a couple lines and cut up that square into pieces. The purple lines on that square have length A, and the green lines are going to have length B. Now A and B are used to represent any length, because it doesn't really matter what those lengths are. We just happen to have two lengths, A and B. What that means is that I have inside my bigger square, I have a smaller square whose area is A squared. And then I have a medium-sized square whose area is B squared. Remember that to find the area of a square, you square its side length, or you multiply the two sides together. B times B is B squared, A times A is A squared. On the right-hand side, I cut up the square also with four lines. These four lines connect to make a square inside of that square that seems to be tilted. Now, the purple lines on the bigger square still represent the same length of A, and the green lines will still represent a length of B. So I've cut up the square again into lines that measure A and B, exactly like the lines that measure A and B on the left side, but this time they are in a different order. So A, B, A, B, A, B instead of A, B, A. They follow a different pattern, but the length is the same. The black line inside that I've colored blue now have their own measurement, and because it's a square, because the inside is a square, they each measure what I called C. And it turns out that the smaller square inside the bigger one on the right-hand side now has an area of C squared. On the left-hand side, if I draw a diagonal in the two rectangle boxes, that diagonal has to measure C. And we know this because the diagonal of those rectangles creates two triangles. Those triangles have length A and B. And if we look on the right-hand side, the side length C touches a right angle triangle with length A and B on the other sides. So it must be the same length on both the left and on the right side. Now if I start removing those triangles, those four triangles, you'll see that as I take them away, here I've colored them in yellow, but if I take them away, then on the left-hand side I'll be left with just A squared and B squared, which is the area of the two smaller squares. And on the right-hand side, after I've taken away those four triangles, what I'm left with is the area of the blue square, which is C squared. Now since I started off with the same area on both sides, and I've taken away the same amount on both sides, then I must be left with the same amount, which means that A squared and B squared must be equal to C squared. And that's the proof to the Pythagorean theorem.